Let's show how you actually compile a .x file. Assume that we're using the same squared example as in the previous videos, and the file, the .x file for that example, is square.x. You'll see that by using this .x file, we will automatically generate a bunch of the code that's used for the client and the server-side processing. To do this, SunRPC relies on a compiler, rpcgen, and to generate C code, rpcgen is used with the option -c, so the full command is rpcgen-c and then square.x. That's the .x XDR file. The outcome of this operation will be that a number of files will be generated. First, it will generate a header file, square.h, that will have all of the language-specific definitions of data types and function prototypes. Next, it will generate the code for the client and the server-side stubs. For the client, this is a proper stub. For the server-side code, this actually also includes the skeleton of the actual server, so it has the main routine included. The only thing that's not available will be the actual implementation of the service, of the procedure, and this makes perfect sense since the compiler has no way of knowing what exactly do we want a particular procedure to do, in this case, squaring a number. Finally, the compilation step will also generate a separate file, square_xdr.c, and this will include some common code that's related to the marshalling and unmarshalling routines for all of the data types, the arguments, and the results that are used both at the client and on the server side. If you take a look at the file square_svc, which stands for service, you will see that it has two parts. The first part is the main function for the server, and that will include the code that does the registration step and also some additional housekeeping operations. In addition to main, the stub will contain all of the code that's related to the particular RPC service. So in our squared case, this is the square_proc service, and it is the first version of that particular service. So for all of the procedures in that particular service, the file will include automatically generate code in order to parse the request so as to determine which particular procedure to be called, to generate the arguments, all of the argument marshalling operations will be invoked here, and other steps. In addition, in the stub file, the auto-generated code will include the prototype for the actual procedure that's invoked in the server process. For the square_proc procedure that we described, this is the procedure name, and that will include also the _1 that refers to the version number. And this piece of code has to be implemented by the developer. This is not automatically generated. The client stub will include a procedure that's automatically generated, squareproc_1, and this will represent a wrapper for the actual RPC call that the client makes to the server-side process, where the implementation of the service, the squareproc1 SVC, is actually called. Once we have all of this, the developer then writes the client application and makes call to this wrapper function that looks something like this, y = squareproc of x. This very much looks like a regular procedure call. There is no need to create sockets, create buffers, copy data into the buffers, and this is what makes RPC appealing.